Welcome to the lecture. In the previous video, we created a method in our linked list class. Here is the code for that. We made the add to start method in our linked list class to add nodes to the beginning. Okay, so as we can add nodes to the beginning of a linked list, just like that, we can also add nodes to the end of an existing linked list. Okay, so suppose a linked list that contains three nodes. Okay, a linked list that contains three nodes, and we want to add a new node at the end of the linked list. So what we have to do? We have to loop through each node of the linked list, and when we reach the last node, we are going to then attach its next pointer to the new node. Okay, so this is how we attach the new node to the end of the linked list. Okay, so let us see this in action. Okay, so let us create a add to end method. Okay, and this needs data. So first step is to create the new node. Okay, so this would be an object of the node class, and this node class takes data. Okay, so this is how we create a new node. Okay, so after this we are going to set a variable, and we would be pointing this variable to the self.head. Okay, so the self.head is a variable that points to the first node of our linked list. Okay, so current node is self.head. Okay, now we have to check whether our linked list is empty or it has some nodes. Okay, so we have pointed the current node to the self.head. Okay, and now we are going to check whether our linked list is empty or not. So if self.head is none. Okay, so if self.head is not pointing to any node, that means there are no nodes in our linked list. Okay, so self.head equals to the new node, and self.tail equals to a new node. Okay, so both of these would be equal to the new node, as there is only one node in our linked list. Okay, so we are adding a new node, and if self.head is none, then this would be going to be the first node of our linked list. Okay, so both the self.head and the self.tail would point to the same node if there's only one node in the linked list. Okay, so we are going to return here. This return is very important, otherwise this would not work. Okay, so now we are going to loop over the linked list. Okay, as we have checked for this self.head is none. Okay, so now we are going to loop over the linked list. So if our linked list has some nodes, okay, we are going to loop over it while current node dot next. Okay, so while current node dot next is not none, while current we have to do this. Okay, so while current node dot next is not none. Okay, so we will break out of the loop if the current node's next points to a none. Okay, and when we break out of the loop, we are going to set that current node next, which is now pointing to the none, to the new node. Okay, let us see how we are going to do that. So while we loop, we are going to update the value of the current node. So current node is current node dot next. So each time we loop, we move to the next node. Okay, so this is how we update the value of the current node. So once we reach the node whose next is pointing to none. Okay, so once we reach that node, we are going to break out of the loop. Okay, and we are going to then set this current node dot next to new node. Okay, so so what happened here, uh, we are looping through the list of nodes. Okay, and once we hit the last node of our linked list, okay, once we hit the last node of our linked list, the last node of our linked list next pointer would be pointing towards none. Okay, and we have to attach the new node after the last node of our linked list. Okay, so we are going to break at the last node of our linked list. So after we break from this loop, break out of this loop, we are going to set the next pointer to the new node. Okay, so last node's next pointer will now point towards the new node. This is how we are going to attach the new node at the end of the linked list. Okay, so let us see this in action. So this is the fruit list. I am going to create another list of numbers. Okay, so num list, this is a num list. Okay, and I am going to create some numbers here. So 1 1 2 3 4 5, let us create up to 6 here. Okay, and we are going to create a linked list. Okay, so let us numbers, give it a variable name of numbers. Okay, so this number would be an instance of linked list. Now we are going to loop over this num list variable. Okay, we are going to loop over this, and we are going to insert all these values to the end of the current linked list. Okay, so let us see. So we are going to loop over this num list, and we are going to add all these values to the end of the linked list. Okay, so for element in num list, and we are going to be using this numbers dot add to end. Okay, so this numbers is a instance or an object of the linked list class. Okay, so we can use this add to end over it, and in the data we are going to put element here. So this is how we create it, and now we are going to print this thing. So print numbers, and then we are calling the method print list over it. Okay, so we can now run it and see whether it's working or not. So as you can see, this is one, this is showing 1 2 3 4 5 6. Okay, all connected to each other. So this is the add to the end function. Okay, this is add to the end function. So let me show you, let me tell you how it did this. Okay, so when we added the first element is 1. Okay, so this became the first node of our linked list. After that we looped again, and we got the second element. We entered the second element to the add to end method. Okay, and our linked list now contains one node. Okay, so this second element would get attached after that node. So after 1 we attached 2. Okay, so So after 2 we got 3, and this 3 got attached to the next pointer of 2. Okay, so this is how the end this is how add to the end works. Okay, so we have done two operations on linked list till now. Okay, there are some more operations to it, so we can also look at how we can reverse a linked list, and we can also look at some other things that we can do on a linked list. Okay, so these are some operations that we can perform on a linked list, like length determination means counting the number of nodes in a linked list. Okay, and traversal, which means visiting each node in the linked list. Okay, and performing a certain action on it, like printing it. So we have already been doing traversal while we while we do this print list. So this is similar to the traversal. Okay, and we can also do some things like deletion from a specific position. Okay, so if we want to remove a certain node in the linked list at a certain index, okay, we can do that too. We can also insert a node at a specific index in our linked list. So all these methods I will teach you all this. Okay, so I will meet you in the next lecture.